one thing I love about the scientific method, because chemistry and really with all sciences, you have this type of method, but we really see this in chemistry a lot, is that it makes you think different. Okay. Because with everything that you're going to go through in life, right? You kind of have to do, you can apply this scientific method to that, and for the most part, you can look out there and there's always multiple steps to the scientific method. You can have, I've seen some that has 7, I've seen some that has 4, I've seen some that has, 5, but there's 3 things I'm going to cover specifically with the scientific method that, we see this in every single one. Observation, hypothesizing, and experimenting. Okay. Now, with the scientific method, it's more of a process. Okay. So with the method, right, you're always trying to get to a conclusion of something. Okay. That's the end goal with the scientific method. We're trying to make sure that, okay, whatever I just saw, okay, let me process this in my mind and let me get my conclusion, okay, from there. That's basically how we're going to go about this process, this scientific method process. So the 3 main methods I'm just going to talk about with you guys, because like I said, there's so many out there, but they always, every single type of step process you see always has these three main elements. Okay, let's first talk about observation. Okay, when you observe something. So basically, observation is when you are carefully watching something and then you are recording that data. Okay. For instance, let's look at this observation. There's 2 types of observations here. You have a qualitative and then you have a quantitative. Okay. Qualitative, you can think of this as a qualitative observation is basically there's no type of numbers involved at all. Okay. You are literally describing what you see. So for instance, say I got a pot of water, and I put it on the stove. And what I see happening is that as I increase the heat, right, the water is getting hot. Now, how's the water getting hot? Based on what I observe, I start to see, the steam pop up. I could feel the heat coming off the water. This is literally what I'm observing with my eyes. So there's really no numbers involved at all. Quantitative, okay, is where there are numbers and then there are units involved now. So same thing, that pot of water on the stove heating up. Now, if I want quantitative data, I need numbers and units involved. So what am I going to do? I'm going to go get a thermometer, put it in the water. So that way I could give me a number and unit. So what I see, right, the same thing has happened. The water is getting hot. I start to see steam and I feel that heat coming out the water. But now I got a number involved. So once I see it start steaming and boiling, right, what do we observe for this quantitative data? It's at 100 degrees Celsius. And we know, right, if you didn't know, water boils at 100 degrees Celsius. And this is my quantitative data that I'm observing. Okay. Now, with this, right, observation, that's the first component of the scientific method. Then, right, we got our hypothesis. Okay, so, like I said, you can apply this to every single thing you do, right? There's science all around us. So, with our hypothesis, okay, I see this as I'm observing this water on this pot, right? I got my observation. Let me hypothesize what's about to happen. So, basically, a hypothesis is an explanation of an observation. So what do I think is happening? Well, I feel like the water is boiling, right? So the water is boiling. So what's another thing that's happening? Evaporation is taking place. That's what I'm hypothesizing. Okay, I'm explaining what I just observed. And then, right, that can lead us to our experiment. Okay. So experiment is a controlled procedure designed to generate an observation that is confirmed or refuted by your hypothesis. Okay, so basically your experiment is going to confirm or try to confirm your hypothesis. Now, are we ever going to be 100% right? No, that's not always the case, because somebody else can do an experiment and it might, refute your hypothesis. Okay, so in this case, if I wanted to, still sticking with this pot on water stuff, right? Let's say I want to do an experiment. Okay, I'm going to heat my water up to 100 degrees Celsius. You right? Because my hypothesis was, well, the water boils at 100 degrees Celsius. Okay, well, what if I did it at 50 degrees Celsius? What if I did it at, 1 degree Celsius? What if I did it at 200 degrees Celsius, right? I'm going to do a set of experiments to see if my hypothesis is right. Okay, and this is the scientific method. This cycle of observing something, coming to your hypothesis, and then experimenting. And then from there, you can conclude, right, based on your experiments and all of your data that you've collected. And this is really, right, how you can apply this scientific method to anything we do, right? That's the reason why I say, like, scientists kind of think different just because of this scientific method. We always got to observe something. We got to use some type of hypothesis comes to our head, and then we got to do some type of experiment. And then based off these three things, we can conclude, right, from our data, right, we can conclude everything we just did from this data. And this is the scientific method, and this is happening over and over and over again.